When we have solutions, we need to be able to explain to others what type of solution we have, but we also need to be able to know what the concentration of that solution is, because some of your chemical equations may call for a more concentrated or more dilute amount. So the concentration of something is the amount of solute that you have in a certain amount of solvent. And we say something is dilute when it just has a small amount of solute, and concentrated would be when it has a large amount. Now those are not very scientific in the fact that they give you no exact number. So for instance, I may consider a lemonade that has a lot of sugar in it to still be considered dilute, because maybe I want even more sugar in it. And you may think that, oh, that's really, really sweet, that's very concentrated. So dilute and concentrated are kind of in the eye of the beholder. What you may consider dilute, someone else might consider more on the concentrated side. So, but it gives you an idea, at least, as if you're comparing two items, that this one's more concentrated, this one's the more dilute. So it just gives you a more of a comparison. We also are going to be looking at molarity, and molarity is the number of moles of solute that we have in 1 liter of solution. And molarity is going to be, the unit for that is the capital letter M, which is why you cannot use the lowercase m, because that's meters, and we didn't want to use the lowercase m for moles. So capital M, though, is open and available. So that is what molarity, the unit for molarity. So moles of solute, liters of solution. And it's really important to remember that this is the total volume of your whole solution. That's the amount of liquid that you have. Let's say that it's salt water. It's the total amount of water and salt that you've added together, the total volume, not just the amount of solvent. So if you have 100 milliliters of water, you might have like 103 milliliters when you add your salt to that. So you'd be looking at the 103 is what we would use in this equation, not just the 100, not just the amount of water, but the amount of total solution. So that's really important to remember. M, the molarity, is read as molar. So when you see a specific solution in class and maybe it says that it's 3 with a capital M, we wouldn't say that's 3 molarity. We say that that's a 3 molar solution of sodium chloride. So 3 molar sodium chloride. We have many practice problems to do. There are 5 of them in here that we're going to be practicing with, because molarity is really key. Since we use solutions a lot in chemistry and chemical equations, we definitely need to be able to solve for molarity, or to know how much solution we need for a certain amount or a certain molarity of solution, and so on. So we're going to start off with just a lot of practice problems. So a saline solution, which saline is a salt solution. You see these at hospitals. People get hooked up to saline solutions just to keep fluids going. We have 0.90 grams of salt in exactly 100 milliliters of solution. We want to know the molarity. So remember that molarity is moles of solute, first of all. We are not given the moles of solute, we're given grams. So we're already going to have to do a conversion. And it is also liters of total solution, not milliliters. So we have a few conversions that we need to do before we can even use our equation. Let's start with our moles. Okay, we have grams of NaCl. We want to get 2 moles, and we can do a molar mass. No balanced equation or anything. We're not switching to a new substance. We're just converting grams of salt to moles of salt. And so you got to get out those periodic tables. 58.5. And that's going to give you, with proper significant digits, only 2.015 moles of salt. All right. We also need to know the amount of liters of solution, not milliliters. So we're going to be able to convert, and that had a decimal at the end, milliliters to liters. Every 1 liter has 1,000 milliliters, so 0.100. And now, sorry, that's not milliliters, that's liters. Now we have the units that we need in order to use our molarity equation. So molarity is our amount, moles of solute over our liters of solution, which is 0.100 liters. And when you divide that and significant digit wise, we have only 2 right here. The 0 in front doesn't count. So our molarity is 0.15 molar. So we have a 0.15 molar solution of sodium chloride. Alright, our next one. So in this case we have our 2 liters, a volume of 2 liters, and we know that it contains 36 grams of glucose, and we know that grams is not what we need because molarity is moles over liters. So we want to convert that 36.0 grams, and that's glucose, C6H12O6. So remembering molar masses, that's not going to go away. We're going to be using that throughout all of chemistry. And get out those periodic tables, and if you spend some time and calculate it all up, you should get 180. If we're looking at sig figs, there'd be no decimal because 12 hydrogens times 1.0, you're only 2 significant digits, so you'd have to have 12 point, no decimal place when you're adding everything up. Anyway, just in case you had forgotten, 0.200 moles, and we already have our liters, so we're ready to use our molarity equation. We have our moles, 0.200, and our 2.0 liters, and that is going to give us 0.10 molar. 2 significant digits on that one. Alright, practice problem 3. In this case, we're given moles this time, but we have milliliters, so we're going to have to still do some conversions before we can do this. We need to have liters, so let's convert our 250 milliliters into liters by dividing by 1,000. So 0.250 liters, and we already have the amount of moles, 0.70, and we decided 0.250 liters. Our final answer can only have 2 significant digits, and in this case it's going to be 2.8 molar solution of salt, sodium chloride. Alright, for practice problem 4, we know the molarity. We know the molarity of our solute, but we don't know how many moles that would be. So we also have milliliters, which we know isn't going to work because molarity is moles per liter. So we're going to start off with just converting our milliliters, and you can probably do this without showing your work now at this point, I would hope. But if you still need to, please do. I would rather you do your work than forget and make a mistake. So when we're doing this one, we're going to have to set it up a little differently because now we know our molarity and we know our liters, but we don't know moles. That is our X. So 0.425 molar equals our unknown, because we don't know moles, but we do know our volume is 0.335 liters. So we're going to think of this as over 1. We need to cross multiply. So we're taking X equals 0.425 times 0.335, and we're only allowed 3 significant digits. So our number of moles should be 0.142, and that's moles of ammonium nitrate. Alright, last one you are going to be setting up, but I do want to give you a few hints. So we've done several, actually we just did a problem just like the first sentence here. How many moles of solute are in 250 milliliters of 2.0 molar calcium chloride? So we know the molarity and we know the volume, but first thing you're going to want to do is convert that to liters. Alright? So with that equation, you're going to know the amount of moles, and you'll be able to solve the first question. Now, the next question is how many grams of calcium chloride is that? So my hint to you for that is that you are going to need the molar mass of calcium chloride so that you can convert moles into grams. And I'll be checking this one as I walk around. And if you have questions, like always, please let me know.